much for the introduction. Oh, and okay, and also thank you very much for inviting me to this wonderful workshop. So as I will talk about this one. So this is about something extension of the Nahm equation to the M2 brane in M theory. So this is based on the two papers, a bit old, but yeah, one is with Nosaka-san, and one with Sakai-san. Okay. So first, so 11-dimensional M theory is defined by non-perturbative 10-dimensional two-way string theory. More precisely, M theory on S1 compacification is type 2A string. So radius of S1 is the string coupling constant here. So so this M series is interesting because all string series are unified, and it is not all, but most of the string theory can be considered as a compacification of the M theory. Okay, so and various string duality or some S duality of a field theory is manifest in M theory. So it's interesting. But M theory is described by the 11D supergravity in low energy limit. Okay. So field in 11-dimensional supergravities are three-form field, C, and metric only, except gravity, it's a fermion. So boson is metric and this C only. So if there are charged object in M theory, there should be some corresponding n forms. So in this case, there is three forms only. So in M theory, only the M2 brane. M2 brane is a 2 plus 1 dimensional object. So because this is three form, and its magnetic dual is called M5 brane. So these two, there are only these two types of the branes. And let us concentrate on the M2 brane, which has been significantly understood recently, 15 years ago. And low energy effective theory in M2 brane is given by the ABJM theory, which is just a 2 plus 1D Chern-Simons matter theory. So we can analyze it. This theory is appeared after the very important works by Bas Harvey and also Bacca Lambert and Gustafsson. But I will talk about this ABGM theory only. So M5 brane also very interesting, but mysterious. There is no known action for the multiple M5 branes. Nevertheless, we expect M2 branes knows M5 branes. So this is because, first of all, let us remember that in type 2 string theory, D2 branes knows D4 branes in some sense. Here we consider the D2 brane in a two-way string. First, if there's no boundary, it's described by the Yang-Mills theory. 2 plus 1 dimensional Yang-Mills theory on the D2 brane. And it is well known that D2, from the, if we consider the D2 brane terminated as a D4 brane, then this D2 brane can be regarded as a monopole on the D4 branes. I mean, in the D4 branes, we can, if we consider this X0 direction is 3, 4, 5 direction only, then it's a 4-dimensional. So there is a monopole. So this is a monopole equation. It is described by the D2 brane in a brane setting. Okay, so here, okay. And then, of course, it is well known the monopole equation can be solved by the Nahm equation. Okay, then this Nahm equation is a BPS equation on the D2 branes. Okay, so BPS equation of the D4 branes is the monopole equation, and the BPS equation of D2 branes is Nahm equation. So then this Nahm equation is correspond to the D4 branes. So in this sense, D2 branes knows something about the D4 branes. Okay. Now, 2A string is a compactation, S1 compactation of the M theory. Okay. So if we here we consider D2 brane and D4 brane, bound set of these two branes, then it should be lifted to the M5 brane and M2 branes. Okay. So so we expect M2 brane knows about M5 brane also. Actually, M2 branes is described as ABGM theory. I will explain what's the ABGM theory, but anyway, it's M2 branes. So M2, if we consider M2 brane terminated the M5 brane, then this M5 brane can be regarded as a Soliton solution in the ABGM theory. So this Soliton solution, or the equation describing this solution should be extension or generalization of the Nahm equation. Indeed, in ABGM theory, BP equation for the this M5 M7 bound state is given by these two equations. I will explain what's why or later, but this is by this one. This equation is has a cubic interaction here. And this is not just a commutator, like a Nahm equation or radiator equation or instanton equation. So in this sense, this is a new type of a Soliton equation. So I think this is very interesting. New types.
So where is the M5 brane?
Sorry?
Where is the M5 brane? At x2 equal to 0 or where?
Sorry, I will explain later. Sorry.
Okay, thank you.
So, sorry, I explain. Actually, the M5 lane is located at y is point at y is diverges. So
Okay.
some point y is diverged at in this x2 direction. Okay, sorry. So this is x2 direction, and this direction is declared by y1, y2. And M5 lane is declared by the where y is diverged at here. In this figure, y is diverged at this point x. For example, x2 equals 0 or something. Is it okay for you?
Yep. Thank you.
Okay, sorry. So okay. The solution of these BPS equations should represent the M5 lanes. So those will be important. Yeah. But only a few solutions have been known. But we found at least for two M2 brane cases, we found all solution. And the key factor for the solution is this BPS equation can be written by the Lux pair, our Lux equation. I'll explain. So using this integrable structure rather tricky, we find all solution for 2M2 brane, and this could be a step out understand M5 brane. I will talk about this. But as a Soliton equation, this equation itself are very, I think, important. This is something solvable and new types of the, and I think important equation. Anyway, I will talk about. First, let's remember what's for the D2 D4 case and the Nahm equation and the Lux pair for that. Okay, for D2 brane case, on the D2 brane there is a SUN Yamil theory on that. So okay, so this longitudinal direction is x0, x1, x2, and transfer direction is this one in 2A. And the display effective action is a 3D super Yamil theory with maximal Seiji. So there is 7 scalars and 16 Seiji and SO7 global symmetry, and it's not conformal. We will consider D2 brane, and we will consider N D2 brane, and later we will consider N M2 brane. That means for the D2 brane case, this gauge group is SUN. Our more precisely UN, but UN is decoupled, so SUN. Here, the fields in SUN super is in 2+1 dimension. There is a 7 scalars Ti, which represent the transverse direction of the D2 branes, and Dirac spinors, and also UN gauge fields. Okay, and this is a D4 brane, D2 D4 branes in super Yaml theory on a D2 brane. So we assume this T4, T5, T6, T7, and A mu equals 0, and only these 3, T1, T2, T3 are non-zero, and just a function of x2 only, this direction only. Then the BPS equation for this D2, D5 bound states is a Nahm equation, this one. This is well known, and the D4 branes located at where this T diverges. In this case, if S is or X2 is C, it diverges, then there is a D4 branes. Okay, and actually any solution will becomes this type of the basic solution near the D4 brane. This is X2, and Ri is n-dimensional representation of SU2. It's a n by n matrices for the n D2 brane case. And this corresponds to the fuzzy two-sphere. So this SU2 n-dimensional representation of SU2 can be regarded as a fuzzy two-sphere. It's also well known. So and so this direction becomes fuzzy two-sphere. Okay, so then next I will explain the ABGM theory and the corresponding BPS equation. And the M2 effective action should be 8 scalars because it's 11 dimensional, and 16 Suji and so 8 global symmetry, and conformal symmetry. So it should be should not be a Yang-Mills. And fields in ABGM action is YA. It's a UN cross UN by fundamental representation. Sorry, there is a UN cross UN gauge fields. And also there is a Fermi. And ABGM action is UN cross UN Chern-Simons matter theory, which has a 20 supersymmetry and a C4 cross U1 internal conformal symmetry. And this action describes the N M2 branes of C4 over ZK. So here, the trick is not just C4 or R8, but ABGM action only describes the C4 over ZK. It's orbifold of the C4. But anyway, it is described by just a Chern-Simons matter set. And this is the ABGM action, but we will not use this one, so forget about this. But we can write down the action for the M2 branes. Then we consider the, some bound state of the M5 brane and M2 brane. Here we assume y3, y4 equals 0 and a equals 0 and y1 and y2. These y1 and y2 are now complex. So there is a Fourier degree of freedom. And the y and y2 are the function of x direction only. Then the BPS equation for this M2-M5 bound state is given by this equation. Here, y dot is derivative with respect to s, and a equals just 1 and 2. Okay, so this is coordinate. This is x2 or s, and this direction is xl, x1 to this M2 brane. But here we consider the this solution is uniform for this xl and x1, and this y1, y2 direction is so this is a 4 real space. And if y diverges, then there will be an M5 lane, like M to M, D to D4 bound state case. Okay. And any solution and will becomes following basic solution near the M5 lane. Here, this x, but there is a square root here, not a 1 over x. And the SA is should satisfy these types of the equation. And this can be diagrammed by the symmetry of the theory to this one. And this is in some sense interesting because this should represent fuzzy three sphere because there is a additional one direction. This is something interesting because fuzzy three sphere not, I mean, auto-dimensional fuzzy space is very difficult to realize. So, but here, this should represent the fuzzy 3D sphere. Okay. Anyway, okay. So this for this basic solution case, this diverges at x equals 0. So this describes the M5 brane at x equals 0. Number of the M5 brane is dimension of this SA. Here, so in this case, dimension is n. So this describes n M5 branes. Okay. Okay, so there is some comment. For the Nahm equation case, some shift of the variables is also a solution because this is a commutator and there's a derivation. But for the for the ABGM case, this shift is not does not give the solution of the BPS equation. Okay. And also this I mean ABGM action has some D3 algebra structure shown by the Bakker and Lambert. Here, okay, so 3 bracket is like a user bracket or commutator, but this defined here, in this case, defined by this one. This satisfies these fundamental identities. This is the analog of the Jacobi identity, but it's not unsymmetric. Okay. And then the BPS equation is indeed written by this 3 bracket. Okay. So this is generalization of the 2 bracket and should be related to the number bracket or something like that. And this structure is also very interesting, but it's not understood clearly in M theory or in mathematically. But it should be important to understand the M theory or something. But anyway, here we just comment this equation can be described by the 3 bracket. Then we will consider the Lux pair for the BPS equation. And for the Nahm equation, Lux pair for the Nahm equation is given by the Hitchin. It means this Nahm equation is equivalent to the Lux equation here. Here A is defined by this one. And lambda is arbitrary constant parameter. And B is given by this one. Then this equation and this equation are equivalent. This is just yeah, this is just equivalent. But Lux equation have some merit. That means this because of this commutator relation, trace of the A to M conserved charge for any positive integer M. Okay. And these are summarized by the spectral curve. Spectral curve is defined by this P. This is a determinant. I mean, this is any. Sorry, this mu should be eta. Sorry. And A is a function of lambda, so it's called the spectral curve. And okay, so these trace AM is all given by this determinant of this type by expanding by eta here. And also we can also introduce this star conjugate type equation. This is just Hermitian conjugate plus some transformation of the lambda to minus lambda bar. Lambda bar is a complex conjugate inverse. Then we find A star equal A and B star equal minus B. So, and now I will consider the so-called linear problem. Linear problem is this equation for given A and B. S is x direction, and lambda is a parameter. And this psi is so this is something like a linear equation for this psi. Eta is just a constant, so this is something eigenvalue. And this is psi. Yeah, okay. This is dot is derivative with respect to s. So a linear problem is, Lax equation is some consistency condition for these linear problem. Okay. And this is a very basic equation for the Lax formalism. We define n by n matrix. We define n by n matrix. This psi, psi is just this psi is a vector. This is n by n matrix, and psi is a vector. And if we this psi1, psi2, psi-n is some independent equation, independent solution for these linear problem. And D is just arranging the eta 1, eta 2, eta n. For this eta 1 is eigenvalue for psi1, and eta 2 is eigenvalue for psi2. And we can define D. Then the linear problems are written as this one. Okay. So this is just yes, matrix version of this linear problem. So now the psi is also n by n matrix, and A is also n by T is also n by n matrix. But of course, these are same as this equation. Here here we have assumed there are n linearly independent solutions for this A psi, but this is assumption, but usually it's satisfied. Then we can reconstruct A from the psi. If we know the psi, the solution of the linear equation, then we can reconstruct A. A is a solution for the original Nahm equation. Here, C is defined by this one. D is eigenvalues, and N is something like a matrix, but something like a normalization matrix. Then if insert this one to here, then this is given, this gives A itself. Okay. So this is a known factor about the Lax pair for the Nahm equation. Now, next we will consider the Lax pair for the ABGM equation. So ABGM equation is given by this one. This has a symmetry given by this one. This U and V are independent SU2. SU2 matrix, and lambda AB also independent SU2. And this U1 is also in yeah. So this the symmetry of the equation is greater than the Nahm equation. Nahm equation case it's SU2 cross SO3, but it's something extended. Okay. And for this equation, for this equation, we find the corresponding Lax equation given by this A and B. Here, yeah, so by the like a 2 by 2 matrix. So here y1 is n by n matrix. For this A is a 2n times 2n matrix, and B is also 2n type 2n cross 2n matrix. Lambda is a arbitrary constant parameter. Okay. And this is the same as the Nahm equation. Trace A to M are conserved charge. And in this case, spectral curve is given by this one. And because of this A is this form, it's factorized. So then it becomes this. So eta square only appear. So we will denote eta square as mu. We can also introduce a chirality matrix, this one. And then we find A anti-commute with gamma and B commute with gamma. Actually, B can be written by this one. So, okay, this follows from this. But yeah, there is a natural chirality matrix. Of course, in a M theory side, M2 brains point of view, I don't know what's the meaning of the chirality here, but at least for the BPS equation, we can introduce this chirality matrix. So yeah, and we also introduce a star conjugate, and these are same for the Nahm equation, but yeah, we can also introduce this star conjugate. Then we will consider the linear problem, like the Nahm equation. And because of there is a chirality type structure, so eigenvalues are paired. I mean, if psi is eigenvector with the eigenvalue eta, then the gamma psi is eigenvector with eigenvalue minus eta. So it's always paired. And then we will take for m is 1 to m, for psi n plus m, here m is 1 to n, then we will just take this type of the relation. Okay. Then we define the n by 2n matrix, this one. Because of this equation, it becomes this. And eigenvalue is eta and minus eta for this gamma. So then the linear problems are written as this one, as before. Okay. Then we have assumed there are 2n linearly independent solutions as before, and then we can reconstruct A from S, psi, like before. So this equation is the same form. So if that means if we know psi, then we can reconstruct A, the solution of the equation, BPS equation. Okay. And here, very interestingly, if we combine 2y, like this one, sigma is of course Pauli matrix, then we can construct two matrix, two data of the matrix. And each data, T1, I runs 1, 2, 3. Each data satisfies the Nahm equation. Okay. So there are two Nahm equation for the one BPS equation for ABJ. And we don't know why there are two Nahm equation in ABGM, but yeah, we can show mathematically this one. Okay, and Lux representation also have such a structure. I mean, if we define A alpha and B alpha from this NAM data, two NAM data by this, like user NAM, Lux pair for the NAM equation, then we have these types of equation. B is just a combination of the B1 and B2. B1 is some data for the Lux pair for the each NAM equation, and A squared is this a combination of the A1 and A2. So here square appears here. So this is something similar to the Dirac equation, but also for this case also we do not know why such a structure appears in ABGM. And these relation, I mean these relation means this yeah, spectral curve for the first NAM data and the second NAM data should be equal. So eigenvalue should be equal for these two data. So of course, these two NAM data are not related because this y is same, but it's different, but there should be some relation. And then the linear problem for the NAM equation here, there is a two, alpha labels this A1 and A2. So there's a two linear problem, but this eigenvalues should be same because of this equation. So now consider the original BP equation in ABGM and the linear problem, this one. And then we can express this psi by this one. Here, psi1 and psi2 as eigenvector of A for the corresponding NAM equation. Okay, because of these types of the relation. And this D is eigenvalue for the NAM data. Okay, but for the NAM data, but it's I mean square root of the NAM data. Okay, then we assume eigenvector for the NAM data are given, psi and psi to m. Actually, for the NAM equation, we have some general solution for the n equal 2. So we know.
Me.
Sorry. Yes.
Yeah. Can you remind us what m is, please?
Sorry. M.
Yeah, capital M.
M. M is defined by this one. H is H squared. H is eigenvalue for the the linear problem. Sorry, we introduced many things. Sorry. Yeah. M. Okay. Then yeah. So okay. So NAM data is a given. So then D is this one. So these are yeah. I explained already. And then candidate for the psi solutions of linear problem for the BPS equation is given by this one. Here, psi1 and psi2 are known. Okay, so for this psi, we can reconstruct the solution of the BP equation as this one. But if we introduce a general psi1 and psi2, then it cannot be a solution for the BPS equation because this A has some specific type. I mean, this should be linear in lambda, constant or linear. So this condition. So there is no lambda square, lambda cubic or something. And also, this is a Hermitian metric. So this means this one. have such this one such equation, such this Hn1 and N2 should satisfy this equation. Then if this condition 1 and condition are satisfied, this A should give the solution of the BPS equation. And this should be, if this psi1, psi2 are generic solution of the Nahm equation, then this A, also the solution of this A also should be a generic solution of the original BPS equation. So in this way, we can construct a solution for the BPS equation. It's a cubic type, and but anyway, we can construct such a solution. And yeah, for the 2M2 brane case, we will give an explicit form. First, we consider the general solution for the Nahm equation for n equal to case, but the funnel type. Funnel type means that there is only a default brane here. So, okay, so it's an abelian monopole type. Then the Nahm data is given by this type. This T1, T2, T3 are modular, the location of the D2 brane transverse direction. And X alpha here is just a point of the D4 brane. Here we consider the two Nahm data. So X alpha, X1, the alpha runs 1 and 2, the two. Okay. And okay, and we will choose x1 equals 0 and x2 equals minus L, the two. So this is a generic solution for the funnel type. For this case, Lux pairs can be given by this one. This is by explicit computation. Here M is given by this one, and rho is given by this one. Sorry, rho 1 here is given by this one, and this T lambda is given by this original modular parameter. And then we can solve the linear equation, and the solution is this type. D is a diagonal, basis matrix with this factor. Okay, this is just a direct. This is a result of the direct computation, and then we can compute candidate of A for the BPS equation here. Psi1 is Nahm data. For the first Nahm data, and this is for the second Nahm data. So this is like this one, and we use these types of equation. Then we require the condition 1 and 2 here, and we can solve this equation by hand for this case, and solution for the these conditions are this one. Here. It is a bit complex compared with Nahm data case, but yeah, there is a square root or something like that. There is also a two singularity here and here. But if you consider only the x is positive, then there is a x equals 0 singularity here. So M5 branes at x equals 0, and this is this represents the two M2 branes, and with a symmetry action, this should be the general solution for this funnel type for n equal 2. I mean 2 M2 brane. Okay, so then we find such a solution using Lux type equation. Okay. We can check by if we take x goes to 0, then this y1, y2 becomes a basic equation. I mean, the fuzzy three-sphere one, and the x go to infinity, it becomes a diagonal, and there's a 4 modular parameter. Okay. And then we can rewrite the solution by this type. Here, F1, F2, and F3 is this one. This is just a rewriting of the previous solution here. to here with this. Then we can show that if this F1 satisfies this equation, here and this ijk are all different. Then if this one satisfies, then this becomes a solution of the BPS equation. And of course, this solution include this one, but there are many more solution for this equation. Actually, it's well known that for the Nahm equation case, this Fi dot equal Fj Fk appears for the n equal 2 case. So this is some generation, the cubic generation of such equation. And because of this equation, we can have we can show these are constants. So this becomes just the first order differential equation and can be solved by the elliptic integral. Then we find this elliptic function. Sorry, the solution with this elliptic function represents the two M2 brane between the M5 branes. And the explicit form is given by the. Sorry.
May I ask a question, please?
Yes.
Yeah. Can you just go back to, I think it was about page 50, where you defined the T's and the Y's related to one another?
Sorry, page 50.
The one where you expressed, that one, just back, the one where the key one that gave the T's and the Y's together.
Sorry, then this one?
Yeah, this one.
Yeah.
So if you take your solutions that you now have for the Y's, do they correspond to known Nahm solutions?
Right, that's right, yes. Yeah, because, we can show with BPS equation of the M2 brane, this combination should satisfy the Nahm equation. So if
that's
we
right.
find...
So which monopoles do they correspond to? Your solution, your Y solutions?
This one, sorry, for this Y case, for the...
these ones.
Probably for this one, for this one with this Fy. Then it becomes, I will explain, but this one.
Okay.
Use this type, using elliptic function. Yes, famous. No?
Okay, so this is the charge 2 case. Okay, thank you.
Okay. The expression form is given by the Jacobi theta function here. And this U is defined by S and S0. And the S0 and the omega 1, S0 U star are here, and omega 1 and the tau moduli parameter. So there's a 4 moduli parameter. And U is restricted this region. And they diverge. I mean, this theta diverges at U equal prime I U star. I mean, the boundary of this region. So this represents these types of the solution because there are two diverging points. Okay, and maybe this is a bit complicated, but just elliptic completed by elliptic function. And also we can rewrite it by the wireless pair function because a pair function and Jacobi theta related, and also we can rewrite it by the Jacobi elliptic function. But there is a square root, and this is a bit difficult. I mean, actually, it is very difficult to find this one by hand from the BPS equation itself. But because of the Lux pair and something, we can find such a solution. Okay, then the corresponding Nahm data for the BPS equation, as a solution of the BPS equation is given by this one. And there's two Nahm data, and it's the difference of the two Nahm data is just a point where D4 branes there. I mean, over the where the difference is just a diverging point. It's a different. this solution case. This solution case x goes 0 and x minus L is a diverging point, like this one. Okay, but anyway, we can find such a solution. Yeah. Okay. Okay, so this one. So yeah, actually that's a tricky. We can find a solution for the BPS equation, but we don't know how to find the systematically the solution of the BPS equation. And anyway, so today I will explain the new BPS equation for the M5 brane ABGM. There is some integrable Soliton equation, and which is different from the user commutator type or field strength type. And there is a very simple, beautiful Lux representation, and there is a Dirac type equation, Dirac equation-like structure, and we can find a new solution, and it represents the all. They represent the all solution for two M2 branes. That's I explained, but actually, as we don't know what's Lux pairs or Dirac equation-like structure or something like that in M5 brane or M2 brane, the physical or string theory perspective, and it's very interesting what it's under yeah. And of course, and actually, this is 10 years ago. Fine, but this little research or almost no research has been done so far. So there are many things to be done. I have also working on this field. But anyway, yeah, there are many things. Especially I'm interested in three algebra structure or the reaction to Toda chain. Actually, there's a very simple relation to the Toda chain by the reduction. But yeah, I think there are many things, and it's very interesting to consider these types of equation or the some generalization of these types of the equation. Anyway, thank you very much.
Okay, thank you very much for fantastic talk.